Hello everyone, I'm Petros. I am a student of a school that was previously founded by Elon Musk. And today I interview the ASAT rocket team from one University of Greece that will compete for the 3-kilometer solid rocket at EuRoC.
So I'm Gerasimos.
And I'm Petros. Okay. In English, that's...
No, there's not
There is a direct translation. For my name, there is a direct translation, and that's Peter or Pete or whatever.
Yeah, so you can call me Jerry.
So what's your team story and your mission?
Our team was founded in 2015 by 12 mechanical engineering students from the Aristotle University of Thessaloniki. And in 2016, there was the Department of Rocketry was established. So from then on, we aim to design rockets and spread the rocketry environment to Greece. And now we're building just rockets and try to launch them whenever we can.
As Petros said, it was established in 2015, but it was originally another project, the Aeronautics project, but we're on the project of rocketry. So we pretty much decided to apply for the team together. He joined a bit earlier, I joined a few months later.
About 27 to 30 people in the rocketry department.
How can someone start a rocketry team in an engineering university?
Know that you need, first of all, some engineers from different departments of the facility, such as electrical engineering, chemical engineering, mechanical engineering, maybe someone to organize all of them, an operations team, someone that has to oversee them during the test, so a safety member.
You definitely need an advisor from the university as well, maybe a professor or a PhD student.
Helpful would be any TRA member, but in Greece, they're not so easy to find, but we meet them to events and we talk to them via the internet. So I think that's the steps. If we were in aerospace, if we had an aerospace faculty, it would be much easier. But I think we're doing just fine.
Yeah, mechanical engineers can do many things, so they take most of the responsibilities for the team. And physicists as well.
Physicists, mechanical, electrical engineers, doctors.
How is it like to study in Greece?
We actually study most classes in Greek, besides the English classes and the terminology ones. There are some departments that have established degrees in English in the past few years. The Greek students, maybe all of them, study in Greek. As far as visa is concerned, I don't know what the case is with countries outside the European Union. However, you can access, I think, the universities without a visa. And the cool thing about Greek education is that everything is free. There is no tuition. So and the cost of living is cheaper
relative to other European countries. It's relatively cheap. So about what do we study? I'm studying mechanical engineering, and Jerry is...
I'm studying medicine.
Yeah. We'll have labs that cover every aspect of engineering and medicine and whatever you choose. But the labs that we are most involved into are labs that have to do with into aerospace, but they don't teach us aerospace. They just teach us fluid mechanics, for example, structural analysis, tests that have to do with PCBs. There are some opportunities to study abroad, but they are involved with Erasmus programs that are funded by the EU. There are some free services, just like
the library.
The library. We can borrow books for free. We can use a gym, public gym, for free. We can visit a psychiatrist, I think. Yeah. And there is free food for all the students. We should study more things in English, more subjects in English, to be more fluent.
Compared to the universities in the United States, for example, from the first semester here, the courses become significantly specific to the degree you study. For example, I know in the US you can take classes like economics classes and be a part of my degree. I cannot do that here. However, you can participate in classes from other departments, but it just doesn't add up to the degree.
Have to do mostly with lobbying. For example, you can work in the industry behind the university, but you have to be in touch with some certain professors. And you have to be good at networking. So it's not actually a thing, but it is a thing.
Contributes to networking quite a lot through not just communication with companies and other people that are related to the industry, but also through events that are for the members of the team, in which maybe some companies that we cooperate with or some sponsors can learn more about us and get to interact more and perhaps be a future employer.
Regarding the connection of our university with the space industry, there's not actually a lot of connection, though there is a lab that develops UAVs. That's the closest we have to the space industry, the closest relation.
What is it like to live in a university city?
Our university is located inside the campus. Actually, not all of it, but most of it is inside the campus that's located in the center of the city. So you pretty much are close to everything regarding transportation. And most of the students live around the university. So there's just like a town inside the actual town that's made up from students and teachers. There may be some resting time during the afternoon.
Or maybe not.
Yeah, maybe not. But not sometimes, actually quite a lot. We used to go out during the weekend.
Yeah, it's quite a big city. It's the second largest city in Greece, so there's quite a few things to do on a night out, and there's pretty much something for everyone, I'd say.
And about the university life, yes, there is a lot of fun activities to engage, and there's also a lot of studying, so it's quite balanced.
Yeah, he throws parties quite often. So,
do you have contact with university alumni or those space companies?
We have contact with not actually companies, but rather organizations such as the TRA. We have some mentors. Most of them were or are. They have a level 3 degree in the TRA, so that's the closest we can get to the space industry. And we have some members that have switched teams, former members of our team that have switched teams. Most of them are studying abroad now. And that's our connection to some companies and universities.
After they leave the team, can take up an advisory role, and we can easily contact them and ask them questions regarding our newest projects or something they might be working on currently in a different company or industry-related team. What
preparations did you do before university?
Every student, like Panhellenic exams, which are the national exams for that students need to take to get into university, and you need to prepare for that. Most people do in high school with private tutoring because high school isn't quite enough to prepare you for
most of the times it's not enough.
And as far as Space High School or Association, we're not aware of such thing existing in Greece.
Yeah, we hope that someday there will be a space high school.
Elon Musk can do something about that as well. Are you still enrolled in the Astra school or Astra Nova? How is it called?
Okay, so this is as a story, a long story. So there was once upon a time, there was a certain Elon Musk and he made some children. After a certain amount of time, these children needed to go to school. So he made Ad Astra. But then what happened? Elon Musk had to move to Texas, and there was also the COVID pandemic. So what happened is practically Elon Musk has left the school, and the remaining school went online, and that is Astra Nova. And there is no correlation, let's say, with Elon Musk right now. The same teachers of Ad Astra, but there's no Elon Musk.
So how was the experience? Was it something extraordinary or... was it like a regular school? Okay,
so it's definitely a higher level than most schools. There hasn't been any funding from Elon Musk from the start of the pandemic, practically.
Just imagine that every summer you will go to a certain place that is hidden from all of us, of our common people, and you will study something related to space and magic. Or
he already uses magic to make his cooling
or
systems.
Just too advanced science to develop rockets and stuff. Just replace the magic from Harry Potter with rockets, and that will be your story.
Yeah, you should write a book about it.
Yeah, I should write a book about it.
I think there will be like a copyright problems.
Yeah, surely.
Harry Potter.
What are your goals and strengths as a team, and what is your roadmap towards space?
Competing in the Spaceport America Cup that will take place in June in New Mexico. We hope to launch the second rocket ever for our team. And later this year, we plan on participating in the European Rocketry Challenge in October in Portugal. Hopefully launch the second version of Andromeda, which is our rocket's name, which will include an air brakes,
an air brake system, and a motor that we designed and manufactured.
Yeah, an SRAD solid motor, and perhaps SRAD electronics as well. Now, as far as the long-term goals are concerned, it's mostly what Petros said earlier, which is to make rocketry more popular in Greece and spread it through these kind of projects to all university students that actually want to participate in a team like ASAT.
Yeah, we actually want to show people that making rockets, it's accessible to everyone. As far as if they want to do that, if they want to commit to that, it's accessible. So everyone should do that if they want to.
Model rocketing is not significantly advanced in Greece, so that might help in that regard as well.
Yeah.
If someone wanted to join your team, how could he?
We would advise to visit the site of our team, asat.gr, and then you will be able to read about us and sign an entry form. The entry form will be reviewed, and then some members will come in contact with you. There will be an interview, and if everything goes well, you will be part of the team. Most of the times, members find us through recruitment events. So we should include that as a step. There's the recruitment event where you get to meet the team, ask questions, and then there's the actual procedure to get in the team.
Yeah, and the ideal candidate would be someone that's really passionate about rocketry and excited to learn new things. The person doesn't have to be from our own university. We actually have members from other universities and universities in other cities as well. We ask potential candidates hypothetical scenario in which a candidate has to choose between delivering an assignment before a deadline, but incomplete and not properly tested or written, or deliver the assignment after the deadline, but after it's properly completed. So that's a question to see which are the priorities for this candidate. There isn't a correct answer, by the way.
Yeah.
We just want to see the thinking process of the candidate.
There is no age limit, but there is a limit regarding the degree you're studying. For example, a PhD candidate can't actually join.
You have to be an undergraduate.
Yeah,
student.
You have to be an undergraduate.
What can someone learn by joining your team?
There are actually lots of things you can when joining our team. Specifically, when a student tries to get into the team from the engineering area, they don't know all the stuff they should know in order to design a rocket. So they must learn them from somewhere. That's us. Knowledge flow from each member to another, and you get more advanced as you progress through the team. For example, when I joined the team, I didn't know anything about fluid mechanics or aerodynamics. Then my boss just told me, you have to study those things and then get trained into CFD or other programs, and that's how I learned some of the procedures.
When he says boss, he means the subsystem coordinator.
Yeah, I call him boss.
How do you manage your team?
Hierarchy. In the team is there's a project lead in the rocketry project, because we have the other project as well, and the marketing department. So inside the rocketry, there's a project leader and the coordinators of each subsystem. And in each subsystem, there are members who cooperate inside the subsystem and perhaps do other errands inside the team that are needed. There's the aerodynamics subsystem, and he's a part of it.
Yeah.
There's the propulsion subsystem. There's the avionics subsystem. I better get all of them right. There's the recovery subsystem. There's the automatic control subsystem, which is a newly founded one. There's the structural subsystem, the operations subsystem, and the subsystem that determines the rocket's mission and basically renders the rocket useful or not, which is the payload subsystem.
And there is a part of the payload subsystem, as you can guess.
Yes.
Yeah, that's all the subsystems.
I think that's all. I'm sorry if I missed anyone.
Yeah, you
to the
didn't.
members of the team that are watching.
How important are the public relations for you?
Yeah, they're extremely important. There's a specific subsystem in the marketing department that's called public relations, and it's very important for us to promote the projects we're a part of, since, as we said earlier, the team's general mission in the long run is to promote rocketry in Greece. Keeps in touch with sponsors and other companies that as an advisor for us. And there is actually another subsystem inside marketing, which is the one, which is extremely important as well, because it promotes our work in our YouTube channel, Instagram, LinkedIn, everything. So there has been companies and there have been companies and people that contacted us because of the promotion on social media. I don't know if you were one of them as well. And yeah, it's been crucial. It's been crucial.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Ignition.
What are your plans for EuRoC 2022?
First of all, we would compete in the 3 kilometers with an asteroid model this time. Yeah, and that's our plan actually, to design and manufacture a whole rocket ourselves and integrate an airbrake system that aims to close up the gap between the apogee and the targeted apogee and the actual apogee to 3,000 meters. And our previous experience was very helpful because it was the first time we actually launched a high power rocket. And it went quite well, I'd say. And yeah, that's our plans, that's our experience. And the only thing we learned is that our top competitor is only ourselves and what we can achieve.
Last year's launch was extremely helpful because we pretty much redesigned the whole thing, everything we talked about during the preliminary design, the conceptual design, and yeah, we pretty much redesigned everything, and we plan on doing better this year. So we'll see.
Do you want to join other rocket competitions, like, for example, Spaceport America?
Yes, as we said before, participating in Spaceport America Cup was one of the rocketry department's biggest goals since its foundation. So we're very excited that we will be part of that in June. Yeah, and competitions are extremely important for us, not because of the we're that competitive, but because, as Petros said earlier, we cannot actually launch our rockets in Greece. So we have to take advantage of every opportunity for a launch that is given to us. And this is unfortunately only through competitions. So yeah, that's why we're planning on launching twice this year in the 2 competitions.
How much do you build your own rockets?
We process the materials, but we don't actually build that much of it. For example, we buy the aluminum, but we don't actually cut the bulkheads ourselves, though we try to polish them in order to fit perfectly. We get the tubes, but we polish them in order to fit perfectly. we paint the rockets. The only thing we actually do construct ourselves are the fins. We purchase the carbonate cloth. We wrap them around aluminum cores. We have a resin infusion process that strengthens them, and then we polish them to shape. There's the motor and the matches, the igniters, the propellant that we actually construct for the rocket, as we said before, that would take place in EuRoC, would take part in EuRoC. Besides that, we purchase the other stuff. Oh, and we actually design our PCBs and some electronics ourselves. Yeah, NOSCON is a tube, actually. So yeah, we construct the NOSCON too.
How do you finance your team?
Sponsors and companies outside the university. We are a part of the laboratory of
fluid mechanics and turbo machinery.
Of fluid mechanics and turbo machinery, and the biggest the marketing department actually is mostly responsible for finding ways to finance the projects. Besides the FR team and the social media team, there's the PR team and the social media team. There's the FR team who reach out to companies either for them to provide us with some of their products or for financial contributions. Yeah, so that's mainly the way the project is financed. COVID, pandemic, and perhaps the war in Ukraine. They've been major issues. Last year, 2 years ago, at the start of the pandemic, it was extremely hard. That you could not get out of the house, as you probably know, and the projects were hindered a lot.
Relative to Greece, we're close to an industrial area, so that's how we find some materials we need.
I am organizing the Open Launch Initiative, which is like an idea that different teams could go to a spaceport, which is sort of expensive, and they can divide some of the money is required. Would you be interested in joining this idea?
Yeah,
absolutely.
Yeah, it would be the best thing for us. We have actually read something about it before. Yes, we want to be part of it. I don't know if we can actually help that much financially, but we would be interested in learning more about it.
Yeah, and wherever that might be in Europe would be amazing as well. Yeah, because we actually did we get in touch with launch spaces in
Poland?
In Poland.
Yeah, I think that there was an idea, but we didn't actually get in touch with them because the financial stuff would be much higher than actually launching in a relative source. Their country, in a country that's more close to us.
Do you have an idea of where this would be?
It could be Spain, Poland, or Norway. I'm not really sure yet.
Yeah, we would like to go there.
What about the amateur rocketry in your country and abroad?
Things aren't quite good in that area. Our country doesn't even have any laws about launching high-power rockets in Greece. There are some laws about UAVs or RC planes, for example, but nothing that has to do with rockets. So we can't actually launch anything. We can't even contact the authorities in order to launch. If we contact them, then they take our petition and it goes further up and it doesn't end up anywhere because there's not actually the law there to support us or deny us the launch, the clearance to launch. So we can't launch yet. And that's the sad story. And that's how we feel about us compared to Europe.
We keep in touch with other teams as well. Yeah. The guys that participated in the last year's European Rocketry Challenge.
Where do you test your rockets?
We can test some of the components, test the materials themselves or some mechanisms we design. We can test our engines during static tests, and we can test our recovery mechanisms with drop tests. I don't know if we can count as a test the flight at the EuRoC22, but for us it was actually a test, and it helped a lot as a test because we gained valuable data through telemetry, and we gained mostly experience during the whole procedure, from the moment we left Greece, during the actual launch and the recovery of what remained of the rocket and the shipment back home.
The first competition the team took part in, which was EuRoC 2021, was critical for us to get a taste of what a bigger, the logistics of a much harder transportation and of people and products would be like in Spaceport America this year. So yeah, not only the data we gathered from the rocket, but also the data we gained from the whole procedure was invaluable.
And regarding the actual launch, we were we were getting ready to launch in Greece. We were trying to find someone that would let us launch in there. Some legal. The problem was that even though our rocket is designed to reach 3 kilometers in apogee, we thought that it would be around the 3.5 kilometer diameter circle during the touchdown phase, and that was actually quite good because of the wind in Greece. The wind in Greece is quite high in some areas, so we tried to launch. Then we couldn't find the actual backing, so we didn't launch. And the only launch we had was the EuRoC one. So the only fun story is from the EuRoC experience. And there was a moment when our electronics shut off 3 minutes before the launch window was closed, and we only had one chance to launch. So a guy from our team ran to the field and back in order to rearm the electronics, and he was named the sprinter after that. Yeah.
Also, the ideal spaceport would be probably a launch place like Spaceport America in Greece, close to where we're located, but probably with less heat.
Yeah.
How do you design the engine and the rocket structure?
We start from a program called OpenRocket. I'm sure you've heard of it. And that's our theoretical backing for actually designing the rocket. Firstly, we do that actually, and then we move to more advanced programs that simulate thermal analysis, fluid dynamics, finite element analysis. And then we actually design, manufacture and test some of the parts that we can test.
Do you use a commercially bought solid rocket engine?
Yeah, we used to use one, but we will actually use one in SAC 2022. We won't use one for EuRoC 2022, and I hope that we will never use one, ever again, because I'm a big fan of hybrid and liquid engines, and I hope that someday that will be implemented in the team.
But that's a task for the propulsion subsystem.
Yeah.
So whatever they decide.
Do you have any plans to use a thrust vectoring or movable fins or not?
Actually, I don't think that we can use movable fins, only if the movement is symmetric to the axis of flight. But thrust vectoring was an option, but we opted firstly to design an air brake system because we thought it would be easier to design. And that's actually part of the automatic control subsystem. They are newly formed, so their first project is the air brakes design. So after they are finished with the air brakes, there may be a thrust vectoring.
Do you use trapezoid fins? If yes, why? If not, why not?
Yes, we'll use trapezoidal fins because they're actually easier to calculate during the theoretical phase of the design, and they're quite easy to manufacture too. They're reliable, they're stable, their structural integrity is quite high. Put them together easily. We can take them out of the rocket fairly easily. And there was actually a plan for tube fins, but it's not yet confirmed or anything. But we would like to use some of the tube fins or test them.
Did you develop your own PCB?
Yeah, for the European Rocketry Challenge this year, we're designing our SROT PCB flight computers and also an SROT PCB for the air brakes system. Yeah. They're both STM32 based, since Arduino is not fast enough, and the STM design is quite more efficient. And all the sensors and the components are selected by through research on their datasheets and following the manufacturer's suggestions and guidelines. Every part has to meet the requirements of the electronics for the launch operations. Actually, we do not have a camera on our rockets yet. We have one for the payload, but that's something we'll discuss later.
Did you design your own recovery system?
Yeah, we actually designed quite a lot of the parts that are involved in the recovery procedure. We show our own parachutes and test them accordingly to ensure that the descent of the flight is normal and stable. We ensure that there is a drag and a main parachute for dual deployments. The parachutes are actually packed together inside the front of the rocket, and they are packed together following respective guidelines that we implement on the rockets. And there's actually lots of tests regarding the recovery procedure. And also we use swivel links to allow rotation without the parachutes being in danger of tangling. And we also test them by use of drop tests that we can actually conduct, at least.
And shout out to the recovery subsystem, which is a single member currently.
We're in the phase of designing an actual air brake recovery, not a recovery, an air brake system, phase that the rocket is moving upwards. And that actually consists of the actual mechanism and the electronics behind it that control it. And we opted for a simple design in order not to into lots of trouble with the actual manufacturing of the components for the rockets, of the air brakes. So yes, we hope that it will be quite advanced sometime, and we hope that next year the air brake system will be actually quite.
Do you play KSP?
If you could tell us more about it, we'd love that.
So KSP, which is stands for Kerbal Space Program, is program which is game, but is also a simulator where you can build a spacecraft using some pods, and you have a small solar system. And you practically can do anything you want in it. You can build rockets to go to orbit. You can land on the moon. You can make aircraft. And most of the rocketry teams I've interviewed play this game, but some of them don't.
How high did they score on the competitions? Maybe that's the key. To scoring high points.
I should do some statistical research about that. Two teams that play Kerbal have higher points. What is your payload?
Our payload this year is biological nature. Last year it was
a radiation experiment. Let's say.
Yeah, it was an experiment regarding that was supposed to measure the dose of radiation in troposphere. Was it? Yeah. So this year is a biological experiment. It will the structure is. We plan on having a microscope-like structure inside the payload bay. So that means it will contain a camera and magnifying the appropriate magnifying lenses. The goal of the experiment is to record a blood sample and from a patient with sickle cell disease and observe its performance. So there will be two phases. The first one will be during the ascent and after the liftoff. More specifically, and the goal is to see the effects of that hypergravity has on red blood cells. And the second phase is about the sickling of the sickle cell disease. It will actually be a deployable payload, and the plan is to observe how the red blood cells are affected by the lower partial pressure of oxygen that exists in high altitudes. And so hopefully we'll have footage of cells sickling during descent. And the plan is to compare this data with data we have gathered from laboratory experiments here on Earth and compare the two.
What do you plan to do in 2022? Do you want to announce something?
Everything is already announced.
Yeah, everything is already announced.
The
competitions, the projects, new members, already existing members, past members, partnerships. Yeah, whatever. They're all already announced.
Yeah. So the things that are left to be decided is maybe some new events, because we are participating in STEM exhibitions and fundraising and sponsors. Communications with sponsors are always happening. So when everything happens, it's almost immediately announced through our social media and to the members of the team. And as far as competitions, only the two that were mentioned earlier.
EuRoC and Spaceport America Cup.
What are your personal future plans?
My personal plans are to finish my studies here and then probably move abroad. And after that, study some years more and try to find a career in the aerospace industry. Some of the possible companies would be, of course, the dominant ones, but I hope that there will be some other develops in our nearby area, for example, Northern or Southern Europe. Yeah, but not actually far from that. I don't want to move that far.
Blue Origin is a sponsor in Spaceport America, so maybe. No, but my future plans are pretty much the same, but in a different field of study. Finish my studies as well, perhaps study abroad for a few years, and we'll go from there.
Or we can actually find a new company. Us two. We've been together since 7 years old, way separate now.
Yeah, sure. Maybe if Etto wants to join.
Yeah, we'd like you to join.
Yeah, I'm also considering to start a new company. Although if we all starting new companies, then there's going to be too many new companies.
We actually start an RC rocket company.
What's that?
RC, radio-controlled rocket company, just like miniature toys with rockets, but actually advanced rockets.
I don't think Etto likes that idea.
What? You don't like that idea?
I don't know how you would do it, and I think you would need a pilot to use one of those.
Well, that's simple, that everyone will be able to fly a model rocket, right? Like 1 meter long and with thrust vectoring to be advanced.
I think you just revolutionized the
space
exploration. Yeah.
Thrust vectoring ain't easy. I know that.
Yeah, we know about that.
Okay, what advice do you have for young rocketeers?
To stay committed as much as they can, to ignore every difficulty they found and just learn from it, and to watch a lot of YouTube channels, because these are the guys that actually provide us with the inspiration to continue doing what we do. And if they have the opportunity to see a launch for themselves in person, they should do that. It's an awesome experience. And if they can be part of a launch that takes people.
What are your favorite space movies?
I think most people have already said Interstellar, so let's stick with that. He's a Star Wars fanboy.
Yeah, I'm a hardcore Star Wars fan. I don't know if it's actually a space movie.
They are fighting in space, so I think
So,
yes, space movie.
It's a movie. Yeah. So yes, I'm a hardcore Star Wars fan. So
The other one has Jessica Chastain in it. So
yeah, but it actually has lightsabers. How cool is that?
what are your favorite ones, Etto?
I like Interstellar and Star Wars too.
Yeah, but you have to decide which one.
You're the tiebreaker.
Yeah.
And that's the hard part, because there's also The Martian.
Oh, The Martian. Yeah, that's a cool one as well.
That's a depressing one.
But Star Wars, the last team of Scotland, he also preferred Star Wars, and he asks this question: how much power do you think Yoda has? Like so who do you think is the most powerful character, like by default?
Wait.
Obi-Wan's the coolest one, so that's the only thing that matters.
The coolest one is Obi-Wan, but the most powerful one is a guy that didn't have any actual flesh. I can't remember how it's called. He was a Sith Lord, Darth.
Is he called the Force?
No.
No, maybe it was like Yari or something.
Darth Nihilus.
how much power do you think he could output? Like, if some way you could make, like, you could use the force to spin a turbine, how much power do you think that would make?
There's actually a scene in a comic that he is dying and he's trying to get some power from something, and he drains the life from an entire planet. An entire planet. So I don't know if we can imagine of how much power that is.
Do you think he has enough power in himself to power a country?
In himself, I don't know how
Before
fast
draining it from another source.
he will drain it probably from something else, but he has the power, I guess. Ask George Lucas, I don't know.
Do you have any questions for me?
How did you get involved with rocketry in such a young age, and what are your plans?
But I always had something with rocketry, and it was mostly towards like the propulsion. The engines are mostly towards bipropellant, liquid-fueled rocket engines. But lately I've been having some interest with tripropellant and also jet engines. I have decided that I would do my education, so high school, then university. I'll probably go to Delft, but I'm not sure yet. And then I plan to start a company. I'll make some investors invest in the company and they can have like royalties. And I think that company is going to be about selling cooling that doesn't require electricity. And I've done some successful tests.
Really?
Yes.
That's incredible.
I've been using magic over these days. I'm joking.
You have the power, the force inside you.
What's today's May the 5th? If it was May
so
the
close.
4th, May the 4th be with you.
Yes.
Close enough.
Yeah,
Wait.
so your company won't be a competitor with ours, apparently.
For now, for the foreseeable future, then what I'm going to do is I'm going to sell the company and I'm going to start a new company that does rockets. And my idea to do this is so that I can get the money without having to have like investors which invest in you to get some of the money, some of the small amount of money that the rocket company makes.
So do you support any sports clubs?
No.
Okay, so that's
me neither.
What's your favorite video game besides KSB?
Yeah, that's a tough one.
Yeah, so I don't really play video games, but like the only one that I can say that is not KSP is Minecraft, because it's the only one that I play really sometimes, like once a week.
You should try Clash Royale.
It's a mobile.
It's a mobile game, yeah.
What else are you into? Are you music or something?
So I'm doing some music. I'm not that good at music, but I am the best in my class. Okay, I should say that I do Astronova, but I also do another online school, which is Avionics.
Yeah.
And I do an Italian school, which is in person, and it's normal middle school.
Wow.
Oof, too busy.
Yeah, that's way too much education.
Yeah, I might agree. And in the Italian school, there is I'm in a musical class, and so I do the violin.
That was a lot.
Yeah.
I used to like the violin so much, but I didn't have the chance to play it because my parents wanted me to play the guitar. And when I turned 18, I switched to electric bass. So yeah.
He's a musician himself.
Yeah, you're a musician too, remember? Yeah,
Right.
he's a pianist. Part-time.
Yeah. Rocketry has taken most of my time now, so
Yeah, I do prefer rocketry. I do some stuff which is somewhat related to rocketry because I have like a budget of let's say that on average I spend maximum $1 a week, because I very rarely buy something, and I just keep on reusing everything that I have. So that's why my rockets are made out of cardboard practically and clay.
and clay as well.
So they're practically made of rock and paper. Okay, I got a 3D printer, so they're made of PLA. They're not. I don't use clay anymore. But I have over there, I am building a furnace because I thought it would be nice to have the ability to make some metal parts.
So you want to not only you want to take the primal material and then melt it and.
I don't want to go mining. I want to grab like aluminum cans or something, and I want to melt them. I do not plan to go mining.
Start from aluminum cans and finish with what? With the whole engine.
Sorry?
You want to start from aluminum pans, then melt them and use them as whatever everything you have in mind. You want to actually melt the metal.
Yes.
Wow.
And this is going to be my 4th attempt. The problem is that clay has this tendency to break when it dries.
Yeah.
So currently my furnace is in 3 pieces, and I don't know what to do.
And you have only clay to use. Clay.
Okay, so I've got it's not really a secret. It's like the cookie dough recipe that just goes with very good at withstanding heat.
Yeah.
Very good. So I just line the inside with like a couple of millimeters of this cookie dough, and it keeps the heat.
You could try to bury it, to just like open a pit, and then use the cookie recipe for insulating. And then
Unfortunately, my house is made of concrete.
dig in the concrete.
That's likely too advanced for me. I can only make a cardboard pickaxe.
Maybe next year, yeah. But that's the spirit of an entrepreneur.
Yeah.
You with $1 a week to build stuff.
Yeah, that was impressive.
Also, I've got an Arduino.
Oh.
I haven't done much. I'm not that good with electronics, but I
understand all of them, but
I still don't understand how just a bunch of transistors, which are like gates, which are on or off, can allow us to make this interview.
Yeah.
Hundreds of kilometers at a distance. How?
Yeah, it was a pleasure.
Yeah, it was a pleasure for me too. Thank you for joining this interview. And if you're someone watching, please like, comment, and subscribe to my YouTube channel.
Like and comment on Etto's YouTube channel immediately.
Yeah, and click the notifications button.
Yeah, turn on the notifications. Great to meet you. And if you want to do anything like interview related, or if you're interested in any of the stuff our team makes, or any of the new projects, we'll be glad to communicate, and perhaps we'll
meet someday.
Yeah, and we'll invite you for a podcast of our own, maybe one day.
Oh, that would be great.
Especially when you start.
Yeah,
when you establish your newest company.